It is given that two different sound sources S1 and S2 have frequencies in the ratio 1:2. Source S1 is approaching towards the observer and S2 is receding from the same observer. The speed of both S1 and S2 are v each, and speed of sound in air is 330. If no beats are heard by the observer, then the value of v is. So according to the given question, assume that an observer is over here and a source S1 is approaching towards the observer. This is moving towards the observer, and let's say its frequency is n, or emitting sound of frequency n, with a velocity take it as v. And there is another observer, take it as S2, is receding from the same observer, so moving away from the observer with the velocity v. And if the frequency of S1, source 1 is, if you are taking it as n, then frequency of second one is taken as 2n. Speed of both S1 and S2 are v each, and the speed of sound in air is 330. No beats are heard by the observer. So if beats are not heard by the observer, that means the apparent frequency heard because of the first source and the apparent frequency heard from the second source should be same. So in the first case, the source is moving towards the observer, then the apparent frequency is actual frequency into n into c divided by c minus v. And in second situation, the source is moving away from the observer, so the apparent frequency is actual frequency 2n into c divided by c plus v. And as a value of beats frequency is equal to 0, that means n1 minus n2 is equal to 0, or you can write n1 is equal to n2. So we can write it is n into c divided by c minus v is equal to 2n into c divided by c plus v. So we can cancel this n and the c. So we can write the c plus v is equal to 2 times of c minus v, or we can write a c plus v is equal to 2c minus 2v, or you can write the value of this 3v is equal to c, or the value of v is equal to c by 3. According to the question, the value of c is given as 330, so it's 330 divided by 3, that is equal to 1110 meter per second.